This is part one of our lesson on multiplying radical expressions. Now, in part one, we're going to look at the simpler types. So, first of all, let's remind ourselves this. So, this is going to be a quick review. So, remember when I had the square root of x to the sixth power? Do you remember what that equals to? Now, again, always assume for our purposes that the variables represent positive numbers. But do you remember what the square root of x equal? So remember, you would say, since this is 6, the exponent is 6, then you'd say 6 divided by 2 is 3. So do y'all agree that the square root of x to the 6 is x cubed? Because, remember, because x cubed times x cubed is x to the 6. So when you multiply like bases, you add exponents, right? So also remember when you did something like this, the square root of 20 x to the 5th power, remember what you did there? So what you did there was you rewrote this as the square root of 20 times the square root of x to the 5th. Remember that? And then you simplified the square root of 20. So you asked yourself what perfect square goes into 20. So you went off to the side and you said, well, I know that 4 is the largest perfect square that goes into 20. So I'm going to say that's going to be the square root of 4 times the square root of 5. And so then this is square root of 4 is 2, so you get 2 square root of 5. So that was this right here, right? Okay, so then we went here, and then we asked ourselves, we said, all right, so I want to make it look like this, somewhat like this, where since the index is 2, that's even, I want this to be an even number, because if that's an even number, then I can rewrite this without a square root. Okay, so then we said, well, what's the largest even number, since that's even right here, square root 2, was the largest even number less than 5? Well, we said 4, right? So we rewrote this right here. We rewrote this as the square root of x to the 4th times the square root of x, because x to the 4th times x, when you multiply like base, you add exponents. So at 4 plus 1 is at 5. And so the square root of x to the 4th then becomes x squared, square root of x, and that was right here. So that became x squared, square root of x. Okay? So now we remember we said this, all right? So I have a square root of 5 and I have a square root of x. So you can put those together. So when the indexes are the same, you can write this you can write the product as one radical. So the square root of 5, this right here, square root of 5 times the square root of x is the square root of 5x. All right? And then so we have 2 times x squared times the square root of 5x. All right, and so that's what this is. So this is 2x squared times the square root of 5x. All right? So another thing you got to remember is this, that when you have the square root of 6x times the square root of, let's say, 2x, okay? Square root of 6x times the square root of 2x, do y'all agree that's going to be the square root of 12 x squared? 6 times 2 is 12. X times x is x squared, right? And then that kind of looks like this. And so I can kind of do all some work around on this side. So let's talk about the square root of 12. So you want to simplify. Make sure you always simplify whenever you can. So the square root of 12 becomes the square root, remember the largest perfect square that goes into 12, so that's 4. 4 times 3, right? So it'll be 2 square root of 3. All right, so this right here becomes the square root of 12 times the square root of x squared. And the square root of 12 is this, so that's 2 square root of 3. Now, the square root of x squared, that's easy because that's even, so it's 2 divided by 2. Well, that's 1, so that's just x, right? So that's 2 square root of 3 times x. So 2 square root of 3 times x. Just make sure the x is not underneath the square root. So make it look something like this. All right. Now, if you have this, the square root of 5x times the square root of 5x, let's talk about that. All right, the square root of 5x times the square root of 5x. Well, the square root of 5x times the square root of 5x becomes the square root of 5 times 5 is 25, and x times x is x squared, right? All right, well, let's rewrite it like we did here. Break it apart again, so that becomes the square root of 25 times the square root of x squared. What's the square root of 25? That's easy. 25 is a perfect square, so what's the square root of 25? Well, that's just 5. And what's the square root of x squared? Well, that's just x, because remember the square root of x squared is x because x times x is x squared. All right, the radicand. All right, now here's what I need to talk to you about. Also remember that when you had from a previous course, so this is from a previous course, that when you had 2x minus 3 times 2x plus 2, let's say plus 5. Plus 5, how'd you multiply this when you had those two binomials? You use the FOIL method, right? So let's use the FOIL method. So you can use FOIL to multiply two binomials. So what's 2x times 2x? Well, that's 4x squared. What's the outer? Well, the outer is 10x, right? What's the inner? Well, that's a negative 6x. And what's the last? Negative 3 times 5 is a negative 15, right? So now combining like terms, I get 4x squared. 10x and a negative 6x is 4x. And then minus 15. Okay? All right, now let's look at this. All right, so we're going to use all of these things here, everything we just saw, 1 through 5. We're going to need that as our background for what we're about to do now. Okay, so now let's look at this. So this will be number 6. All right, so the direction is going to say multiply. Multiply. Okay, suppose I had the square root of x plus 3 times the square root of x plus 2. All right, square root of x plus 3 times the square root of x plus 2. All right, so I have two binomials, right? So I can use the FOIL method. Okay, so let's think. What's the square root of x times the square root of x? All right, I'm saying the square root of x times the square root of x. Well, do y'all agree that's the square root of x squared? And if I simplify that, that's just x, right? The square root of x times the square root of x is just x. It kind of makes sense because what's the square root of 5 times the square root of 5? It's just 5. What's the square root of 7 square root of 7? It's just 7. What's the square root of 6 and the square root of 6? It's just 6, right? So what's the square root of x and the square root of x? It's just x. All right, and that's true because the square root of 5 and the square root of 5 is the square root of 5 squared, which is 5, and the square root of 7 squared, which is 7, and the square root of 6 squared, which is 6. Because 6 times 6 is 6 squared, 7 times 7 is 7 squared, 5 times 5 is 5 squared. So when I use a FOIL method here, the square root of x and the square root of x is x. The outer, now be careful, so the outer is square root of x times 2, so you have to write it like this. You must say 2 square root of x. You got to put that number in front. And then the inner is a positive 3 square root of x, and then the last, 3 times 2 is 6. So I have x plus, now let's talk about this. These are my like terms. 2 square root of x's plus another 3 square root of x's gives me 5 square root of x's. And then plus 6. Now these three terms, they're not like terms. See, this term contains x. This is not x. It's the square root of x, and this is your constant. So that's all you can do. All right, that's all you can do there. Okay, number 7. Suppose you had the square root of x minus 5 times the square root of x plus 3. All right, let's try that one. All right, square root of x minus 5 times the square root of x plus 3. So again, FOIL, you have two binomials. So FOIL, square root of x and square root of x, we already know what that is. That's x squared. Well, square root of x squared, which is x. The outer, the square root of x times 3 is positive 3 square root of x. The inner, negative 5 square root of x. And then the last, a negative 5 times 3 is a negative 15. Combining like terms, I can combine these because 3 square root of x and a negative 5 square root of x is a negative 2 square root of x. So that's x minus 2 square root of x minus 15. And those three terms, none of them are alike, so you're done. That's your answer. Okay? All right, number 8. Suppose I had the square root of x plus 7 times the square root of x minus 7. Square root of x plus 7 times the square root of x minus 7. Okay, so let's use the FOIL method again. So the square root of x times the square root of x is the square root of x squared, which simplifies to x. So I get x. The outer is a negative 7 square root of x. The inner is a positive 7 square root of x. And the last, a positive 7 times a negative 7 is a negative 49. Now, you see, when I did these, I combined like terms, and I had 2 square root of x plus 3 square root of x is 5 of them, 5 square root of x. 3 square root of x minus 5 square root of x is a negative 2 square root of x. What is a negative 7 square root of x and a positive 7 square root of x? That's 0, right? So all I get is x minus 49. That's all I get, x minus 49. All right, number 9. What if I had this? What if I had the square root of 2x plus 7 times the square root of 3x plus 2, let's say. All right, so square root of 2x plus 7 times the square root of 3x plus 2. All right, no big deal. Let's just do FOIL method. FOIL method. I have two binomials. The square root of 2x, here's what you have now, the square root of 2x times the square root of 3x, right? All right, what's the square root of 2x and the square root of 3x? Well, that's the square root of 6x squared, right? All right, so let's simplify this like you did in a previous lesson. So that becomes the square root of 6 times the square root of x squared. Can I simplify the square root of 6? Is there a perfect square other than one that goes into 6? No. Can I simplify the square root of x squared? Yes. So that's the square root of 6 times x, right? Okay. So that's going to go here. So that's my first. Now be careful. Don't make the x look like it's under the square root. Okay, so it's not this. Don't make it look like this. That's not true, okay? It's not that. Okay, now the outer. The square root of 2x times 2 is 2 square root of 2x. The inner, 7 times the square root of 3x is 7 square root of 3x. And then the last, a positive 7 times a positive 2 is a positive 14. Now see those four terms? None of them are alike. See, this is just an x. There are no other x terms now. See, that's the square root of 2x. That's the square root of 3x. Those are not like terms. Those are not like terms. And so you're done. So you can't combine any like terms. There are no like terms. No like terms. Okay, no like terms. All right, number 10. All right, number 10, suppose you had the square root of, let's say, 3x minus 2 times the square root of 3x plus 2. Let's say we had that. So it's very similar to the one we had earlier where we had the square root of x plus 7, square root of x minus 7. Let's just see what happens. All right, using the FOIL method, the square root of 3x and square root of 3x. Okay, the square root of 3x and the square root of 3x, if you want to work it out, you can. That's going to be the square root of 9x squared, right? And so that becomes the square root of 9 times the square root of x squared. What's the square root of 9? Well, the square root of 9 is 3. What's the square root of x squared? Well, that's just x. But you knew that was 3 your x, because remember a while ago we said the square root of 5 times the square root of 5 is 5. The square root of 7, the square root of 7 is 7. The square root of 6, the square root of 6 is 6. So if the radicands are the same, it's just a radicand. The radicands are the same, right? So it's just a radicand. So that's 3x. The outer is 2 square root of 3x. The inner is a negative 2 square root of 3x. And the last is a negative 4. Now these I can combine. Those are like terms because I have, see how these are the square root of 3x's? I have a positive 2 and a negative 2, so that becomes 0. And all you're left with is 3x minus 4. And that's your answer. Those are not like terms, obviously, so you're done. Okay, 11. Suppose I had the square root of x plus 3 squared. Square root of x plus 3 squared. Well, just like you had in a previous lesson, you have a binomial times itself. That's what that means. A binomial times itself. Okay, so now let's FOIL this out. So if I FOIL the square root of x times the square root of x, is x. So I get x. The outer is 3 square root of x. The inner is 3 square root of x again. So remember in a previous lesson where you had 2x plus 3 squared, let's say, and you folded it out. You wrote it out like this first. That's that same idea. All right, except this time you're dealing with radicals, and here you're dealing with polynomials. And so 2x times 2x is 4x squared. The outer is 6x, and the inner was also 6x, and that's the idea here. So when you multiply a binomial by itself, the outer and the inner are going to be the same thing. The outer and the inner are going to be the same thing. And then 3 times 3 here was 9, and so you got 4x squared plus 12x plus 9. So here, the square root of x and square root of x is x. The outer is 3 square root of x. The inner is 3 square root of x. And then 3 times 3 is 9. Combined like terms, these are the only two terms I can combine because this is 3 square root of x and this is also 3 square root of x. So they both have the square root of x. So you just add their coefficients. 3 plus 3 is 6. So that's x plus 3 square root of x plus 9. I'm sorry, 6. 6 square root of x plus 9. Okay? 12. Suppose you had the square root of 3z plus 2 squared. Square root of 3z plus 2 squared. All right, same idea. So if I rewrite it as two binomials, square root of 3z plus 2 times the square root of 3z plus 2. All right, FOIL. The square root of 3z, write it out if you have to. Write it out. Square root of 3z times the square root of 3z. Do y'all agree? Well, first of all, you already know that that's going to be 3z, right? Since the radicands are the same. So if you multiply it out, you get 3 times 3 is 9. Z times z is z squared, right? So it becomes the square root of 9 times the square root of z squared. The square root of 9 is 3, and the square root of z squared is just z. So that's, so you get 3z. So that's 3z. The outer is 2 square root of 3z. The inner is also 2 square root of 3z. And the last, 2 times 2 is 4. So I have those four terms. The 2 in the middle I can combine. 2 square root of 3z's and 2 square root of 3z. See, those are like terms because the radical expression is the same. Square root of 3z, square root of 3z. Okay? So all you do is add their coefficients. 2 plus 2 is 4, so you have 4 of them. So I get 3z plus 4 square root of 3z plus 4. Now, you're done. Now, don't make the mistake of thinking that these two are alike because you say, well, they both have 3z. No, they don't. This is 3z. This is the square root of 3z. Those are not like terms. All right, so you got to remember that 5 and the square root of 5 are not the same thing. Okay, they're different. Okay, so there's your answer there. That's all you do. All right, 13. In 13, let's suppose we had this instead. Let's suppose we had the square root of 5x minus 2 times the square root of 5x. Oops, sorry. Let me write it like this. The square root of 5x minus 2 squared. Square root of 5x minus 2 squared. Okay, so again, you're going to write it as two binomials. So that's the square root of 5x minus 2 times the square root of 5x minus 2. Okay? All right, now let's FOIL. The square root of 5x times the square root of 5x is just what? Real quick, what do you think it is? It's 5x. You know it's 5x. Now, if you want to multiply it out, you can. That's going to be the square root of 5 times 5 is 25. X times x is x squared. So that becomes the square root of 25 times the square root of x squared. Square root of 25 is 5. Square root of x squared is x. So that's just 5x. The outer is a negative 2 square root of 5x. That's the outer. The inner is a negative 2 square root of 5x. And the last, a negative 2 times a negative 2 is a positive 4. And then again, notice that these are like terms because they both contain the square root of 5x. Now, that's why they're like terms, because of that square root of 5x. The radicands are the same. That's why they're like terms. So you add their coefficients. A negative 2 and a negative 2 is a negative 4. So this becomes 5x minus 4 square root of 5x plus 4. Do y'all understand that these are not like terms, right? Because this is not the square root of 5x. This is just 5x. So you are done. That's all you can do. All right? So this was part 1. So in part 1, I need for you to understand, and if you understand basically in part 1, how to multiply two binomials which are radical expressions. All right? So make sure you go over 6 through 13 again. All right, so make sure you can do those. And then remember the prerequisites were these right here. 1 through 6 were the prerequisites for you can basically understand what's happening here. So that is multiplying radical expressions part 1. All right, so part 1.